Something is shooting at Earth. Right now, as you listen to this, invisible bullets are slamming into our atmosphere at nearly the speed of light. Some of these particles carry more energy in a single proton than a professional baseball pitcher puts into a fastball. They've been hitting us for billions of years, and for over a century, we had no idea where they came from. That mystery is finally being solved, but what we're finding is stranger than anyone expected. In 1912, a physicist named Victor Hess climbed into a hydrogen balloon with 3 radiation detectors and rose to an altitude of over 5,000 meters. The prevailing theory at the time was that all atmospheric radiation came from radioactive elements in the Earth's crust. If that were true, radiation should decrease as you got farther from the ground. Instead, Hess found the opposite. The higher he went, the more radiation he measured. Something was bombarding Earth from above. He even flew during a solar eclipse to rule out the sun. The radiation didn't change. Whatever was hitting us came from far beyond our solar system. Hess had discovered cosmic rays. He won the Nobel Prize for it in 1936. But the real mystery was just beginning. Over the following decades, scientists learned that cosmic rays are mostly protons, some helium nuclei, a smattering of heavier elements. They arrive from every direction in the sky at energies that dwarf anything humans can create. The Large Hadron Collider at CERN, the most powerful particle accelerator ever built, smashes protons together at about 6.5 trillion electron volts. The most energetic cosmic rays carry 100 million times more energy than that. A single subatomic particle, smaller than an atom, carrying the kinetic energy of a thrown baseball.
What in the universe could possibly accelerate particles to such speeds?
Here's the problem. Cosmic rays are charged particles. As they travel through space, they get deflected by magnetic fields, bouncing around like pinballs through the galaxy. By the time they reach Earth, their original direction is completely scrambled. We can measure their energy, we can count how many arrive, but we cannot trace them back to their source. For 100 years, physicists could only guess. The breakthrough came from gamma rays. Unlike charged particles, gamma rays travel in straight lines. They don't care about magnetic fields. And when ultra-high energy cosmic rays slam into clouds of gas in space, they produce gamma rays as a byproduct. Find the gamma rays, and you find the accelerator. That's exactly what a massive observatory high in the mountains of China set out to do. The Large High Altitude Air Shower Observatory, or LHASO, sits at 4,410 meters elevation on Heizhi Mountain in Sichuan Province. It's a sprawling array of detectors covering over a square kilometer, designed specifically to catch the highest energy gamma rays ever observed. When a gamma ray hits the atmosphere, it triggers a cascade of secondary particles, an air shower that spreads across a huge area. LHASO catches that shower and works backward to determine the energy and direction of the original gamma ray. In 2021, LHASO announced it had detected gamma rays from 12 sources within our galaxy, with energies exceeding 100 trillion electron volts. These weren't ordinary sources. They were PeVatrons, objects capable of accelerating particles to at least 1 peta-electron volt, 1 quadrillion electron volts, 1,000 times the energy of the LHC. For the first time in history, we were seeing the guns that had been firing at us. But the real bombshell came later. In February 2024, LHASO revealed something even more extraordinary. A giant bubble of ultra-high energy gamma rays in the Cygnus star-forming region, spanning over 100 square degrees of sky. Inside that bubble, they detected individual gamma rays with energies up to 2.5 peta-electron volts. The math was inescapable. Somewhere inside that bubble lurked a super PeVatron, an accelerator capable of boosting protons to at least 20 peta-electron volts. That's 1,000 times more powerful than anything humanity has ever built, and it's been running for millions of years. So what is it? What kind of object could possibly generate such violence? The leading candidate is a massive star cluster called Cygnus OB2. It contains hundreds of young hot stars, each one blasting out stellar winds at thousands of kilometers per second. Where those winds collide with each other and with the surrounding gas, shockwaves form. Particles get caught in those shockwaves and bounce back and forth, gaining energy with each pass, like a tennis ball between 2 approaching walls. This process, called diffusive shock acceleration, can theoretically boost particles to PV energies. Cygnus OB2 appears to be doing exactly that. But it's not the only candidate. In late 2025, researchers identified a pulsar wind nebula as another likely PeVatron. Pulsars are rapidly spinning neutron stars, the ultra-dense cores left behind when massive stars explode. They generate incredibly powerful magnetic fields and shoot out jets of particles at relativistic speeds. The Crab Nebula, the remnant of a supernova witnessed by Chinese astronomers in 1054, has been confirmed as a PeVatron. A star that died 1,000 years ago is still accelerating particles to energies beyond human comprehension. And then there's Cygnus X3, a binary system where a compact object, likely a black hole or neutron star, is devouring material from a companion star. As matter spirals inward, it forms jets that blast outward at nearly the speed of light. In December 2025, researchers published evidence that Cygnus X3 is producing gamma rays up to 4 peta-electron volts, and those emissions pulse in sync with the system's orbital period. The accelerator isn't just powerful, it's rhythmic, like a cosmic heartbeat. What we're learning is that PeVatrons aren't one type of object, they're a category. Stellar explosions, spinning corpses, feeding black holes, colliding winds, all of them capable of building particle accelerators that make our best technology look like toys. The universe is full of these engines, running constantly, flooding the galaxy with high-energy particles that eventually find their way to Earth. There's a feature in the cosmic ray spectrum called the knee. Around 3 peta-electron volts, the number of arriving cosmic rays drops sharply. Physicists have long believed this marks the upper limit of what galactic sources can produce. Anything above the knee, they assumed, must come from outside the Milky Way. But the super PeVatron in Cygnus is accelerating particles far beyond the knee. The boundary is more complicated than we thought. Our galaxy is more violent than we realized. This matters beyond pure curiosity. Cosmic rays constantly bombard Earth. Most are stopped by the atmosphere, but some reach the surface. They contribute to background radiation. They affect airplane electronics. They may even influence cloud formation and climate in ways we don't fully understand. Knowing where they come from helps us understand the environment we've evolved in, the invisible rain of particles that has been falling since before life existed. The hunt for PeVatrons is accelerating. LHAASO continues to survey the sky. New observatories are being planned. Neutrino detectors like Ice Cube in Antarctica can detect particles that even gamma rays can't reveal. The Cherenkov Telescope Array, currently under construction, will provide unprecedented resolution for high-energy gamma-ray astronomy. Within the next decade, we may have a complete map of the galaxy's most powerful accelerators. Victor Hess couldn't have imagined any of this when he climbed into that balloon over a century ago. He discovered that something was hitting Earth from space. He just didn't know what. Now we're finally answering his question. The universe is full of particle guns, and they've been firing at us since the beginning. The next time you look up at the night sky, remember that invisible bullets are passing through you right now. Most are harmless, absorbed by your body without effect. But each one carries a message from a distant cataclysm, a stellar explosion, a feeding black hole, a collision of titanic winds. They've traveled for thousands or millions of years to reach you, and we're only now learning to read what they're telling us. A 100-year mystery isn't just being solved, it's being replaced by something even bigger. What else is the universe doing that we haven't learned to see yet?